Everybody able to see my screen?
Yes, sir.
Very good. So last class, what we discussed is about OSI model. This OSI model is a reference model, a networking model only. Okay. It's a reference model of all different networking model. There is a different networking model. What networking model we are using is TCP IP model we are using. Okay. So not only TCP IP, there are a lot of other models also there, IPS, SPX, Apple Talk like that. So different networking models are there. So by understanding of OSI model and its 7 layers, by understanding what is their functionality, you can understand any kind of OSI, any kind of networking model. So why should we understand? For a understanding of network function, how it is communicating, okay, and maintenance, monitoring, troubleshooting purpose. This OSI model is very helpful. Okay. So what are the layers? Yeah, it is. So for example, you are sending and receiving like from PCA to PCB communication. The communication between two systems, one is A and other one is B. From A, the networking layers are like this. OSI model. First is application, presentation, session, transport, network, data link, and physical layer. So for example, you want to upload a file, or maybe you want to access B system, a printer connected, or maybe you want to send a message like a ping command, you are doing it. Or maybe you are sending a mail. For example, B is a mail server and C is a mail client system. Okay. Or maybe A is a mail server and B is a client system. Okay. Or maybe A is a web browser using like a web client and B is a web server. A is a FTP client and B is a FTP server, like A to B. Or maybe you want to you are sending a message to B directly. Or maybe you are accessing B data. Or maybe you are uploading a data to B system. Are you just doing a ping command, just checking A to B connectivity? So what are the type of communication? So based on that communication, first important is what application you are using. Okay, so what application you are using and what data you are want to send. Okay, so what is your request? What is your data? Okay, request is also contains information, right? What is your data? What is your thing? Okay, and next is based on what protocol, what application, and what data, and very important one is what protocol and what is their port number. Okay, so application based communication. Yes. Okay, so it can be your web browser is an application, or maybe it is a web server application. Okay, server application, web server application, or maybe your database client application or database server application. It can be. It's an application, and based on what communication. So what protocol it is? Source protocol. Okay, what protocol? Based on that, what communication or what port number you are using to communicate. So based on your type of communication. So what are the data you are sending? The data in the presentation layer, okay, it will be encoded, compressed, and encrypted in case of you are doing encrypted based communication, right? Next, what are the data it is? So the PDU of your application layer, the PDU packet data in it, in that layer data is called data only. In a presentation layer, it is encoded, compressed, and encrypted. So this the PDU of the data is format is changed to ASCII format, then it is compressed, then it is encrypted, but still the PDU we call it as data only. Then in a session layer, a session ID is created. So when you are initiating a communication or when you are replying to the communication, okay, when you are initiating communication means you are start sending. So that time only a session ID is created. All your data is attached to the session ID and your authentication and authorization information added to your session. Authentication and authorization, your authentication details or your information is added to your session, the session ID. Okay. And that session will be maintained till the complete transaction of communication. Once communication is completely done, uploaded successful, downloaded successful, request and request reply, we got a reply. Okay, so you send a request, you got a response or reply from the destination. Communication is done. Till the time the session has to be maintained. So session layer, creating a session, maintain the session, terminate the session, creating a session ID, attach your data to your session ID. Okay, authentication and authorization information, attach it to your session ID only. Okay, so that is a session layer. Next is your transport layer. The data at a session layer. So we are added a session ID, authentication, authorization information to the session ID and maintaining the sessions. So that is again the PDO, we call it as data only. But that data here in the transport layer is divided into small pieces called a segmenting. Segmenting means chopping the data into small pieces. Okay, so its range is between 64 bytes to 1500 bytes of each segmented size is there. Not less than 64, not more than 1500 bytes. Okay, so it's in between 16 to 64 to 1600 bytes. So it's a segmenting means so chop the data into smaller pieces. So for this small piece of data, segmented data, okay, it is attached a the segment ID. Segment ID means segment related segmenting the segmented data numbering and sequencing. So now it assign the number to these segments in sequence order. So that number is added to your segment plus number of packets you are sending at this time of communication. You are not sending one by one, you are sending. So at a time 4, 5, 10 depends upon the capacity of receiving capacity. Not only sending capacity, not only sending capacity and receiving capacity also depends upon the destination, how many packets can receive at a time. So based on that, it will number of packets it will send. So how many packets you are sending. So that is called flow control and windowing. So windowing means how many packets you are sending. That's called window size. And how many. So that's how many packets destination can able to receive. So that is called flow control. So based on that, window size is fixed, number of packets you are sending. Next is, so your what type of communication? So that based on your protocol and port number, it will decide what is the type of communication. At a destination, what application has to be responded to your request. Okay, you're sending a mail. So, and if destination is mail server, then what protocol it will be respond? What application has to be responded? Mail server application has to be responded. Then how it will understand mail server application based on your protocols only, port numbers. So these protocol port numbers are added, protocols port number. The source port number, destination port number is added to your segmented data. For adding this source port number and destination port number to your segmented data, okay, it will add in a manner of like this. There is a TCP and UDP separate columns are there. Okay, TCP and UDP. Transmission control protocol, that user datagram protocol. So TCP type protocols, their port numbers are added into TCP type port numbers. a P, okay, it's a box, you have to draw like this, okay. So you are using a TCP. For example, your web communication, so 80, and there is a DNS communication, so 53, okay. So while you are communicating, so based on what communication, what protocols you are using for this communication, their port numbers will be added. Source port number and destination port number. Source port number is 80. Of course, destination port number is also 80. Okay. So sometimes source and destination port numbers are different. For example, you take FTP. Source port number is 20, destination port number is 21. Okay. Source port number is 67, destination is 68 for DHCP. Like sometimes protocols are port numbers are different from source to destination. Okay, source and destination, and sometimes both are same. Okay, your source port number, destination port number is added into a TCP and UDP form. What's the difference between TCP and UDP, guys? TCP, transmission control protocol. UDP, user datagram protocol. TCP, acknowledgement based. UDP, no acknowledgement. TCP, reliable. UDP, non-reliable. TCP, connection oriented. UDP, connectionless. Again, TCP, whenever source send data to destination, source is sending data to destination, it checks destination availability. Okay, first it will check destination available. That's called connection oriented. It's not about wide or wireless. Whatever it is, wide or wireless, it is connection oriented only. Okay, so connection oriented means destination is available or not. And it send a packet to destination. Destination, once receive the packet, it returns an acknowledgement to the source. The source understand destination is received. If source received an acknowledgement from destination means source understand destination is received. Source not received an acknowledgement from the destination, source think destination is not received. What source will do? It send the packet again. Same packet, it will send it again. That is a TCP type protocol. UDP type protocol, source send packet to destination. Destination is received or not, source don't know. It is only keep on sending the data. If destination not received a specific packets, it is source don't know. So source, it's a data error may be possible. Okay. So that is a TCP, UDP. Certain protocols are TCP type, some are UDP type protocols. So your TCP wise, UDP wise, source port number, destination port numbers are added, depends upon that protocol, TCP type protocol, UDP protocol. Their port number, source and destination port number is added to the each segmented data. So this each segmented data with a header, network transport header, which contains segment number, number of packets you are sending, like window size, TCP, UDP, source port number, destination port number is attached to your segmented data. That is the total is called as segment. Okay, TCP, the PD is called segment. Like that, multiple segments are created. Okay, and these segments, okay, each segment sent to the network layer. At network layer, what happened? Source IP address, destination IP address, and routing information is added to your segment. So it is called a packet. To this packet, so what we are adding is source MAC address, destination MAC address to your packet, and there is a CRC value is added. What is CRC? Cyclic redundancy check. It's an algorithm which is used to check the data. CRC is an algorithm. It generated a checksum data from your data. It generated checksum data. What is the purpose of this checksum data? To verify the data is good or corrupted. At a destination, when packet is received using CRC, it verifies the packet data is good or corrupted. If data is corrupted, it drop the packet. If data is good, it accept the packet. So this total what we are calling it is frame. The frame is converted into bitstream at physical layer. And this bitstream again convert into bit depends upon your physical connectivity, whether it is Wi-Fi connection or maybe it is Ethernet adapter connection, a normal wide type of connection, or maybe it is a fiber optical based connection. Depends upon the connectivity, it convert into that related signal. So our Ethernet, it is electrical signal. Fiber optical HB adapter is there, the fiber optical based connection, light signal. Okay. One more, that is Wi-Fi, it is wireless type of signal it is. Okay. So this is up to presentation layer. Okay. This is what we discussed in the last class. Guys, understand? Now you got better? Any doubts, questions? So anyway, what are the media you are sending? For example, from PCA, it is a wide medium. And a PCB, it's a wireless media. Anyway, how they are connected. So whatever it is, get me, I'm connected to a switch, B is connected to a something like a Wi-Fi router. Anyway, both are connected. Anyway, whatever it is, it's like no need to be same connection. Okay, so anyway, so PCA and B has to be connected, wide or wireless type of connectivities, which is connected. So PCB receive a signal. Depends upon how what is your physical layer. It is you are receive it, right? For PCB also wide connector, A and B are connected to same switch. So no problem. A different switch, but these switches are connected, no problem. But A is connected to a Wi-Fi router through cable, but B is connected to same Wi-Fi router with a Wi-Fi connectivity. So no problem, still we can able to connect it and communicate it. So what is your B's physical media? It will receive a signal. Okay, so in the signal format, it is received. This signal will be convert again back to the bit stream. Okay, bit stream. Again, this bit stream is converted into frame. And this frame is given to the data link layer. It's we are in a receiving side. It's a sending top to bottom and receiving bottom to top. Data link layer. Check this frame and see the source MAC address. Means what is source MAC address? A's MAC address. And then destination B's MAC address. And there is a packet. And there is a CRC, right? This is what in a frame. Using CRC, it verifies the data. If data is good, it accept the packet. Next, it verify the destination MAC address based on the incoming packets, incoming packet, destination MAC address, it will check it. And is the same destination MAC address based on this physical connectivity, same means both are same destination MAC address. Because our percentage 10%. Sorry, guys. Okay. Where are we? So it will verify the incoming packet destination MAC address. So what is incoming packet destination? it should be B SMAC address. And verify with the B systems, physical adapters, it means NIC's MAC address. Both are same, accept the packet. Not same, drop the packet. Okay, slide it. Next, what is this incoming packet? Source MAC address is ACE MAC address. So it will put a ACE MAC address into a table called ARP table. ARP table. Okay, so like our MAC table only it is. So ARP table inside our system. Okay, address resolution protocol. Okay, there is RARP is also there. That is reverse of this ARP. So ARP table is there. In this one, it will take this incoming packet source MAC address, keep it one side in the ARP table. Next is, so what is the remaining is packet. This packet is given to the network layer. In the network layer, it opens the packet and see source IP address, which is incoming packet source IP is A's IP, destination IP is B's IP. Okay, and then it is your packet, it means source IP, destination IP, segment, right? Your segment. So again, it verify the B's IP address with your B system IP address. If both are same and accept the packet, otherwise drop the packet. And it will check the source incoming packet source IP address, which is A's IP address. It will put it into the ARP table and map those your incoming packet source MAC address, incoming packets source IP address. Put it into a ARP table. So in the ARP table, we have a A's IP address and A's MAC address mapped into the map. Okay. So this is what happened at network layer. So where is the what is the remaining? It is segment at a transport layer. These segments are collected. Segment number 1, segment number 2, segment number 3, like that. These segments are combined here. All the segments are combined at transport layer. That's why it is called end-to-end connectivity. Where it is divided and same place it is combined. Okay, so it's a chopped data into when we are sending data is chopped. When you are receiving data is combined. Next. In this segment, not only a segment data, also we have a protocol data also there. Segment based on segment number, it is arranging the data. Okay, numbering and sequencing, it arranges all the segments combined and created a data. Okay, so we got a data here. Okay, next one more that what is where it is TCP UDP source and destination port number. It verify the port number, TCP port numbers and UDP port number. So based on the port number, system understand what application, okay, what service or what application has to be responded to this kind of stuff. What has to be, which application has to be process this request. Exactly say which application this process. For example, B is a web server, okay, and a web server application process the A's request, right? Understand and process the request, and it has to be give response. So based on this port number, our system understand which application has to be. So it will go to that application part. Of course, in between two are there. One is session, another one is presentation. So this is called the software layers. We said now application, presentation, session. So all three are same. All three are combined functionality. So in a session layer, it will verify the what is the session ID and what data is attached to this session and what is this authentication authorization means identity information, user identity, username, password kind of stuff, or keys, API key like that. It verify the authentication information. Okay, it verify that authentication and authorization information and check the session ID. What is the data is attached to the session ID. It will verify and it save the session ID. Okay, and verify the authentication and authorize to get connected and get the data, the final data, the data. Okay, all data which is attached to session ID will be arranged here at session ID again. At presentation layer, data is encrypted and it is decrypted. Data is compressed, so it is decompressed the data. So data is encoded, so it is decode the data. So finally, the data is kept. So your application layer depends upon your protocol port numbers. So which application has to be respond, that application will take the data and process your data based on user request. And once it is process completed, it will respond, means it will going to reply to the source, means sender. Okay, to A, exactly. Okay, this is reach up to here. So again, it is responding, for example. So then what happened? Again, A contains the data. So that application, again, from that application, again, it will go to the presentation layer. Presentation layer, again, data is encrypted. Data is encrypted, encoded, compressed, and encrypted. And what is the session ID? It is when we are received a data, that time session ID also received, right? It attached to that same session ID only, because both are communicating in a same session. Okay, so it will attach it to the same session ID. Next is, so again, data is sent to the transport layer. Up to here, data only. Now it transport layer, again it will chop the data into small pieces called as segmenting. So this segmented data attached with the now see segment data number, sequence number, window size, TCP, UDP, source and destination port numbers. Okay, protocols port numbers are added to that. Here, segmented data, then it is created a segment. Again, that segment go to the network layer, source IP address. Now source IP address change. Who is the source IP address? B's IP address. Destination is A's IP address. And here segmented data, then packet. That packets are sent to DataLink layer. Source MAC address means B's MAC address plus A's MAC address here to your packet, and use CRC, click redundancy check. Okay, checksum data is added for error checking purpose. Then it is sent to the physical layer. This frame, which is generated at data link layer, convert into bitstream, and bitstream become based on the physical media signal. Again, it is received at a destination to the physical layer in the different based on physical layer device. It is signal format. Based on that signal format, convert into bitstream into signal is converted into bitstream to frame. The frame, okay, sent to data link layer. It check the source IP, destination IP from incoming packet. This time source IP is received. That's B MAC address. Sorry, data link layer means MAC addresses, right? So B's MAC address, destination is A's MAC address, and here packet and CRC. So it's verify the data is good or not, or corrupted. It's a good, accept the packet and check the incoming packet destination MAC address, A's MAC address with a physical your adapter's MAC address. Both are same, then accept the packet and take the B's MAC address, put it into a table called ARP table. Okay. Next, it went to the packet is go to the network layer. source IP, destination IP. B's IP address is source IP, destination is A's IP. It verify the A's IP address and configured PC configured IP address, both are same, accept the packet. Okay, and your segment. So B's IP, again, it will update into the ARP table. And these segments are collected transport layer, source and destination port number, TCP, UDP, destination port numbers are verified, connected to the application, which application process it is. So one by one, session layer, verify the session ID, same session. So it will connect it to that application. Based on the session ID, it will connect it to that application. Okay. And create a new thing. It's like verify the authentication and data. So that data in the presentation layer, again, it is from encrypted to decrypted, decompress, and decoded. And application layer, what application has to be respond, take the data and process the data. Again, if you want to give reply or some information, then it will give. Otherwise, that's it, the communication. So once communication completed, session will be removed automatically. Okay. So this is from source to destination communication, guys. Just learning of only OSI model, it is good. Remembering all the 7 names are very important. Each layer information is important, guys. The two transport layer, mainly TCP, UDP differences are very important. Okay. And each layer, their outcome data. Okay. So for example, data link layer is a frame, transport layer, segment, network layer, packet. Okay. So physical layer, it convert into bitstream and bitstream convert into physical media based signal. Okay. These are also very important in a OSI model. All 7 layers, each layer what they will do it, TCP IP, and each layer like a transport network, data link, physical layer, what is their PDUs, packet data units. Okay, those are all very important. I will explain ARP separately, guys. Just when you are seeing this one, I have written ARP wantedly. So why? Because when we do ARP command, so that time I will tell you the explanation if any time is available. Okay, you guys understand how it is communicate from source to destination. Respond, guys. Sometimes you have to respond, then I will understand whether I'm connected, not connected. Understand,
Yes,
not understand. Very good. Okay. And one more, two more. So I will tell. One is like a troubleshooting with the help of OSI model, because we understand this two-way communication with the help of OSI model. Then we'll see the troubleshooting with the help of OSI model, and then TCP and IP also. So already we are running late. Mainly we took lot more time on this networking. Okay. Yeah. Again, troubleshooting with the help of OSI. So troubleshooting in a different ways. So we already know application layer, presentation, session, transport, data link, sorry, network, data link, and physical layer. Okay. So, for example, from A system to B system, we are trying to communicate. So we are not getting. So first, in a different scenario, it depends upon what it is showing on the system. Any error messages or maybe symbols. we can understand where it is an issue occurred. Or without knowing anything also, you can start from troubleshooting, okay, or with kind of error messages or maybe some signal symbols, we can understand and we can find out exactly where to check it. Okay, so that is important. In a generally troubleshootings, in a generalized troubleshooting, start with the connectivities, power connection, physical connectivities, cable connectivities, okay, LED statuses, like that. So one by one it will start. Sometimes it is not required to do all troubleshooting from the scratch. Sometimes depends upon that scenarios, depends upon that error messages or information, okay, scenario based. So we can start troubleshooting from some simple some areas only. So how to understand this? Anyway, I will start anyway from the bottom. Okay. So network connectivity issue. Two systems are there. You are trying to communicate, but they are unable to communicate. You're sending and not receiving anything. So where is the problem can be there? So one is possibility is physical connectivity, physically connected or not. Whether it is you're connecting through wire. So if you are connecting through wire, it means your wire-based adapter means your Ethernet adapter in your control panel means your network connections window. It shows. 1 second, I will go to the. See this showing a cross mark means that my cable connection is I didn't given. Okay, so that's showing cross mark. If not showing cross mark, it's look like normal like this. It means connected. Okay, and this is a Wi-Fi. Actually, I connected through Wi-Fi, so that's showing a Wi-Fi symbol. If I am not connected through Wi-Fi, it is showing a Wi-Fi symbol, but not this green. It will show some cross mark on the Wi-Fi symbol. So then Wi-Fi is not connected. So connected, not connected. Both systems are connected or not. Both are connected to network or not. Next, both systems are in the same network. Remember, guys, these are the direct troubleshooting in not only now, in the future, you want to become any kind of things working on infrastructure base. These are all very important. I'm not giving any notes. Also see that one. Okay. So I'm going to telling that's it. Okay. So compulsory understand. Two systems are in the same network, means same segmented network. Okay. So then it's the first anyway, both are connected or not. Next is how they are connected. Both are connected through wire. So it means both are connected to same switch or not. Same kind of switch, or maybe both are connected to different switches, but these switches are connected each other or not. Means same segmented connectivity is there. For example, one system is wired connection, other is wireless connection. Both are physically same network or not. See, physically, first of all, wired means I'm connected to a switch. Wireless means I'm connected to wireless access point or a Wi-Fi router. Is this Wi-Fi router and or wireless access point is connected to this switch? Then it is finally one kind of connectivity only. So this is how many things are there. So you have a switch and directly are connected to the switch. That is one. Maybe you are connected to different switches. Is both are connected or not? Then it is again same connectivity. Maybe this is a wireless access point or a Wi-Fi router and you are connected to Wi-Fi router. Through wirelessly you are connecting or through wire you are connecting. And these two are connected or not. So anyway, it has to be connectivity. Connectivity is required. Physical connectivity. If you are going to be work on cloud computing, virtualization in the future, guys, there also connectivity is important. Both are connected to same switch or same kind of security group or same kind of virtual adapter or not, or virtual switches are not. Okay, same port group or not. Like that, there are things are there. So two systems communicate, they should be connected, either physically connected or virtually connected, they should be connected. Directly or indirectly, they should be connected. Okay, in the same network. First one, connectivity. Second is a IP address, always IP address. If both systems are in the same segmented network, means both are in the same network, same LAN connectivity. It means their IP address must be in the same logical network. Means their network ID must be same and host ID is different. Of course. Okay, of course, that is, of course, an IP conflict should not be there, and IP conflict should not be there, and both systems should be same network. Both should be in the same network. Means their network address is must be same and host is different. Next is you have to test the connectivity. You have to check the connectivity. Physically, you are checking connectivity. Second is IP address. You have checked it, and you have to check the connectivity between the system using a ping command. Check the connectivity using ping command. I will show you how to check the connectivity between the systems using ping command also. Okay, ping command. Check the if you are pinging from A, means from A in the command prompt you put a ping with the PCB IP address, and you got a reply from BPC IP address. It means A to B communication is good. Means the direct connection and communication between A and B is good. Okay, so that is a very important. Okay, if it is showing destination host unreachable, request timed out for when you are pinging it, means there is an issue, either physical connectivity issue or A side or B side IP address issue, or maybe B is become unavailable, down, shut down, or maybe a firewall issue can be possible. It's there. So first is both systems are connected and communicated or not. That is a first thing. So check the physical connectivity, IP address, use ping command to make sure both are communicating or not. Next step. Next step. Transport layer. As I said, when you try to communicate, okay, communicate. So what are the type, based on what type of communication? Use that protocol. In transport layer, we are attaching our protocol's port number in a transport layer to our segment, right? So once you are sending at receiving side, it will also verify that port numbers. That protocol or a port numbers are verified at a B. You know, B's internal firewall, if not accepting that port number, okay, B is a web server, but in a B server, port number web server HTTP is not accepting, or port number 80 is not accepting. So then you can't connect it to that web application. When you pinging AB and communication, in pinging, both are communicating each other. But when you're accessing B's web page, B is a web server, A is a client, and B is accepting that port number 80. So where is an issue? B at a B, firewall is not accepting your port, so you are unable to get it. So you verify the basic things, physical connectivity and ping command, both are communicating online. But when you are accessing through web or maybe a mail communication or maybe some FTP based communication or a NFS communication, what are the types of communication you're doing it? But both systems are good, IP is good, both are communicating, but you're not getting response. So there is a possibility that at B side, the firewall issue is there. A and B. So both very better to verify the firewall. Whether it is Windows systems or Linux system or Unix system, check the firewall. So firewall, okay. If necessary, then we are enable the port at a which system is provided like a B side, we are enable that port into the firewall, so it will accept the port, accept the services. That is at a transport layer. What is that? Firewall. port number, port, or a protocol, or sometimes IP address, or IP network. Okay, the firewall is like a security guard. Firewall is a kind of security guard. The firewall contains a list, yellow list, deny list. Okay, so permit or deny list, yellow or permit, and deny list is there. So it's allowed or permitted through firewall. So it will allow. It's in the list, in allow list, it will allow. It's in the deny list, it denies. If not in the allow list, it denies. Okay, so like that it will works. But what are the based on port? Based on the port number, it verify port number is allowed or not. Okay, or deny. It verifies. Allow list, deny list, it verifies. Port number, protocol name, or service name, application name, okay, network, or host ID. All these things will verify this incoming packet. So it will verify all these things, and once it is matches, allow matches is there, it allow. Deny matches is there, deny. Deny is more powerful. Okay. So next is deny overrides everything. Okay. So next is you are allowed, then you are getting connected. Not allowed means it dropped. That's a fine. Next, session wise troubleshooting. You log into a bank account. You log in and you see some details and you went for some tea, and meanwhile, or you are talking in your phone or something, you are checking in your mobile phone, something for your you want to send a amount to someone, like you pass already 1 or 2 minutes, your session will be locked. The session timeout. Done. You have to log in again. IRCTC website, your banking applications, internet banking. These are all running with the timed outs. One timeout, then it is disconnected. I have a virtualization server, VMware ESXi server. So I'm not doing any activities, it will be out. If I'm doing activities, working. Banking, even you doing activity, if you are not doing any activity for next 1 minute, it will be log out automatically. If you are doing any activity, it will give you a 3 to 5 minutes window only. After that, it will log out. So session, when to end session, automatic session time. Second, how long this session is going on, transactions are going on, session has to be maintained. Once completed, it will be gone, right? You download a file, a 10 GB file you are downloading. So 99% is downloaded already. 9.9 GB is downloaded. Somewhere 100 MB has to be downloaded. Meanwhile, internet got interrupted, or you close the browser. Okay. So what happened? Your session will wait for another 15 to 25 seconds. It will wait to reconnect and continuity. But not happen. So obviously session out. So again, you have to re-download it, entire thing from the starting. Okay, that is a session part. So what we are doing is, if you are having a heavy data, 1 GB, 2 GB, 10 GB, 20 GB, like that, you are doing a heavy data, 100 MB, 200 MB, no problem nowadays, because very good internet speed we are having nowadays. But big data, it is very different. So what we do, using a free download manager, internet download managers for downloading data, okay, into your system. Okay, downloading into your system. That's the point. Okay, so what it happen, you're using these type of applications, even the torrent applications also. What happened, it save the session IDs. when you are reconnected to internet, so it will use the session ID and the session status, and it is continuity download. It verify the previous data tracking download and then continue the remaining downloads. It won't download from starting again. Okay, so that is a session. Not only that one, guys. When you do any transactions, like you're paying amount, you're ordering something. So when you're click on the buy now or add to cart buy now, then you choose bank, OTP, and then there is something like a processing kind of stuff, right? So it is rotate and it shows do not refresh or close the tab or close an application or do not press the back button. Okay, so why it is showing like that? So when you given last final, why it is showing like that? Because entire this transaction has to be completed in the same session only. Okay, so if you are refresh in middle, what happen? You close an application middle, what happen? Your session is going to your bank. So with bank, it send a request to bank to your Amazon or a Flipkart or the Swiggy, Instamart or Zomato. It will send amount to that one, and there it will confirm your order and finalize your order, right? But you interrupt the session. You're interrupting the session means bank you detect the amount, not able to transfer to your Swiggy or Zomato or Amazon or Flipkart. So what happened? The amount is detected, but transaction is failure, so occurs. So what we'll do, we'll keep it like that. Sometimes where these network signals are low, these shops also mainly problem with these certain shops where they're putting this um, Phone Pay, Google Pay, the QR code scanning is there, no QR codes, even the swiping cards kind of stuff. So where are they are putting there is no signal. It will take a lot of time to process it. So amount is we are enter the amount we given details amount given enter the amount, select the bank and given UPI pin also, and it is processed. Due to this signal, low signal capacities, horrible signal sometimes, data connectivities. And we don't know the process is going on, completed on. You close the application in middle, we don't know amount will be transferred or not. That amount won't be come back generally. If a transaction failure, no problem. Ultimately, transaction failure is no problem. But transaction successful, bank won't return. So the guys don't return amount, right? Okay. It went to his bank. He is simply an employee. He don't know how to transfer also. And you got in a hurry. So that's a horrible experience. Once in a while, people will get face that experience, right? So that is the session. So this session will take longer time. So that longer time sessions, if it's successful, okay. It's failed also, okay. But it is sometimes it is we are waiting. If you close the application, we don't know what happened in the background. This amount is transferred, not transferred also, we don't. Sometimes it won't update in the history also. Okay, so these are the things that happen. So that's the session ID, guys. Session layer troubleshooting means you always maintain the stable network connectivities. One more example I will give. One day I'm trying to book a ticket, IRCTC booking a ticket, Tatkal ticket. It's opening at 10 o'clock. Okay, it opens every day at 10 o'clock. Tatkal ticket AC. Non-AC is at 11 o'clock. We got a Wi-Fi connectivity. Mine is a 4G mobile and Wi-Fi, very good Wi-Fi. That's a 70 Mbps or 75 Mbps internet speed that time. So very good high speed internet. So I open IRCTC, log in. So 10 o'clock exactly I have to do all these things. So I done login, I select the train and I given all the information. I went up to bank. I given details, OTP, everything, card details, everything. While transaction is going on, power cut, Wi-Fi is off. Wi-Fi is suddenly off. Then what happened? Okay, immediately my mobile phone, it is switched to 4G, right? Wi-Fi is disconnected, automatically will switch it to 4G. Either you get 4G or Wi-Fi. So both are on, but Wi-Fi is primary. Once Wi-Fi is disconnected, immediately it is switched to 4G. So anyway, my transaction become failure because session is changed. Session connectivity, entire connection is changed. Not only just connecting and disconnecting. Okay, not a 10 seconds or 15 seconds waiting. Immediately it is with the network. So my transaction is become failure and the ticket is not booked. And again, we verified I'm trying to re-enter. It's not working. And meantime, tickets are done, completed. No tickets are available. So at 11 o'clock, so next day onwards, most of the time, I don't trust these Wi-Fi's. So when I'm trying to book something like this serious one, I use my 4G mobile. So check the whether good signal is there or not. If good signal, then I will try to use the 4G one. Okay. So why? Because it is pocket. In that time, when there is a bad day, when there is some punishment day, that time only it will take a revenge. And up to that one, it is very good. Only that time. So simply the session is changed. My Wi-Fi to 4G. Transaction failure. So you have to verify this session as a continuity section is there or not, like that. Okay. So stable connectivities are very important to make sure that is a proper transactions. And two more are there for troubleshooting is a presentation layer. Presentation layer. So when you open certain websites, it will shows, okay, a kind of error. What is that? It is unsafe. Okay, it shows this kind of errors, right? Unsafe website. Sometimes what we will do, we'll continue anyway type. Means you'll go to the, we'll expand that one, continue unsafe. So why we are getting this unsafe? Mainly encryption based connectivities, we are getting this kind of issue. One is both side, means source and destination side. Source and destination side. So same encrypted type protocol we are using or not. So for example, you are using HTTP, but that web server is HTTPS. So no connection. You are using HTTPS. Other side it is actually HTTP only. No connection. That is one. Second one is there is no connection. No, not at all connection. Page not loaded. Okay, page not loaded. Next is if both are HTTPS, request is HTTPS, response means server side also HTTPS, but still you are getting safety. Means that related certificate is not installed properly, and a server side as well as a client side, or improper version mismatching, client side to server side a version mismatching, or certificate means this SSL TLS certificate is there which encrypt your data with using a thumbprint. It will encrypt your data. That certificate is expired. RSA, SSL, TLS. Okay, these certificates, that encrypted certificates, are expired. That time also you can't able to connect it properly. So you got this kind of errors. One more is there. Time synchronization. Your actual server is one time zone. It is time zone wise. You must your time must be sync based on your time zone. The time has to be sync with your server. So your server running correct time with the same correct time zone, correct time it is running. But your time is different. So today is it's the 27th. Now it is 11:18. So in my time it is showing 11:18 p.m. Instead of AM it is a PM. Or maybe it is showing a 9 AM. So there is a time difference. How much difference allowed also there. So last time what happened to one of our sir, I shared some videos, right? 2 videos, service desk videos. So there is a person, right? SI processor. So sir actually try to open this AWS account and he log in successfully. AWS login successfully working. So what happened when he is trying to create this VPC, virtual private cloud, in that one, any resource he creating, S3 bucket or anything he is creating, it's not creating. It's showing errors. He does not understand what happened to his account. He deleted an account. And we try with a different account. So in that time, I got a doubt and said, is time in the system always 5 minutes ahead? Okay, ahead time. So in your system, so we try to change the time to normal time. As per my system, I will change the time to normal. So now what happened? It is open and working. Guys, this type of issue, mainly encrypted based communications, whether what are the things, it can be web related, mail related, or anything. Most of the communication through network is all encrypted type only. So time synchronization is also very important. When you are getting issues, you tried everything, but also check the time synchronization. So properly time configuration is correct. And based on your time zone, the time has to be configured correctly. Okay. So you either use sync from time.windows.com or maybe reference system. Okay. So time synchronization and SSL or TLS protocol certificate time. Unsafe websites. What is that? It is not free virus. I have that machine and I didn't remember that machine name. It's not OSTK. It is something like that only. FreeNAS is an that has an this is TrueNAS. Yeah, this is the one, open filler. Filler. This is the error. Okay. So when I'm trying to access, earlier it is working fine. This is one of my favorite storage application. So open source type, simple bit. So recently from last 3 years back, I tried it to connect. I got same error. Last year also I tried it, same error. Because the new version is not released, they didn't update internal SSL certificates even for a new releases. And that's become problem because the connectivity there are giving HTTPS. But HTTPS in a backend which is the S3 based related SSL certificate, its date is expired. 3 years back, 4 years back only it is expired. That's why we are not getting connected. It is showing an error SSL version or cipher mismatch. Means the server to client SSL version is different or TLS version is different, or maybe the certificated server is expired. Okay, this is one. Presentation layer encryption. So finally, application layer. Application layer, guys. Application layer means, okay, application layer is all about application. What application you are using for based on what type of communication. So you're accessing a website. So you need a web browser. But other side, also there is a web server must be there. Web server application. If a web server application is not running, the page is not loaded. Web server application is not running. Okay. So your page is not loaded. So what is the troubleshooting? Again, check the connectivity. Using ping command, source to destination communication is there or not. And that is our part, client side. That is the server side. So server side, you have to verify the port number in the firewall allowed or not. application is running on NAT, application service is running on NAT. Okay, that is also very important. Next is 404 errors. Okay, 404 page not found. So you open a website and it is showing a 404 page not found. Okay. For example, you open a URL. Okay. So like this, you open some URL. So website is there, correct, working. But this specific page is not available in the server. That's what it is showing. Sorry, we can't seem to find a resource for we are looking for. As well as see in the title 404 page not found. Okay, 404 page not found. Why you are getting this particular page is not available in server. In server accepting your request, firewall is accepting your port, application also running, but where it is happen, page is not available. Sometimes it will shows like this also. Depends upon that website. It will put the 404 errors. Okay. So page not found. So based on what kind of error we are getting, so on what area of OSI model, based on understanding of OSI, what area we have to verify. So then we have to troubleshoot, we have to fix it. And then make sure it is resolved or not. That is important. This is troubleshooting OSI model. Excuse me guys. Hello. Sorry guys, got an important call. Where are we last? Okay, so this is the way of the communication when you are having a communication issue between in the devices. Okay, so with the help of OSI model, where is an issue? Okay, which area of issue? Based on the scenario, we can understand based on basic verification, like a connectivity issues, IP address, network connectivity issue. We have to check it, and also we have to check the application-based connectivity. So application running or not. Okay, is it encrypted? Then means TLS or SSL, or what type of encryption they are using? Is the encryption is currently the certificate valid? Version is matching. Firewalls, checking firewall wise protocol port numbers are allowed or not, application is allowed or not. These are the main important things to check in the network communication. Okay, so that's it. Up to here. Take a break, guys. Take a 10 minutes of break, and we'll be back in a 10 minutes, like 11:40. Okay, and we'll see the TCP/IP to OSI model comparison, then networking commands and all. Okay, take a break.